In this video, I'll talk about the hydrolysis of amides under acidic and basic conditions. So we can hydrolyze amide functional groups, and when it gets hydrolyzed, it makes its carboxylic acid and an ammonia or amine, depending on what type of amide I have. So when I'm running this hydrolysis under basic conditions, so I want to make sure the basic condition would be some sort of hydroxide. So OH minus, so that could be either like NaOH or KOH or anything like that, so something bases. And it requires heating to hydrolyze the amides. So when the amides gets hydrolyzed, it makes carboxylic acid. So I want to go ahead and have this right there, and it will have the O minus here. So it's not really going to make the acid because this is done under basic conditions. So it will have that acid deprotonated, and that would be one of the products. And your second product, since this is done under basic conditions, and if you see what I really have here is an NH2. So just the nitrogens and hydrogens. So when it gets more hydrogen, it just makes an ammonia, and which very well could be in the gas here, and that will just go away from the solution. But one thing you got to make sure that when you're hydrolyzing an amide under basic condition, you're leaving the carboxylic acid that you're going to make in the form of carboxylate or deprotonated, you can say. But if I was doing the same hydrolysis or the hydrolysis of the same compound but under acidic conditions, so I will be using, let's say, HCl with water or any acid basically, and I will be heating it up. Now, what's really going to be the difference? I will still be making the carboxylic acid that I got up there, but now, since this is done under acidic condition, this carboxylic acid would be protonated. So that would be really the difference. And that would also protonate the ammonia that you're going to make. So it's not really going to be the NH3, but very likely it would make NH4 plus if it stays in the solution. And it may very well just kind of go away because it's going to be in a gas. It may just kind of go away from the solution. But if it does stay in the solution, or the amine that stays in the solution, it will be protonated under acidic conditions. So that's something you want to keep in mind. And a lot of times they kind of worry more about what's going to be the type of, or how the carboxylate or carboxylic acid is going to look like, and not worry too much about the amine. But if you're worrying about both of them, this is how it's going to look like. Now let's try another example. So I want to do the same thing. I want to run this under acidic condition and in a basic condition. So move this a little bit to the left here. So if I was moving this under basic condition, so let's just say NaOH with heat. So always remember, be able to identify where your carboxylate is going to be made, or carboxylic acid is going to be made. Your carboxylic acid is going to be made where your carbonyl group is, which is in this side. And then the side that contains the nitrogen is going to make the amine or protonated amine. So this right there is going to be your carboxylic acid. So I can say that I'm going to be making only 2 carbons here. So let's call this 1 and 2 just for my own convenience. So this would be 1, this would be 1, and that would be 2 here. So I would be making a carboxylate here, since this is under basic conditions. And I'm also going to be making this amine here. I'm just going to copy that, change this to this color, and it just gets another hydrogen on there. So I'm not going to get a positive charge on that because this is done under basic conditions. So that would be your side product on that. But if I was doing the same reaction under acidic conditions, so under acidic condition, what's really going to be the difference in the product? So let's just talk about that. I'm going to go ahead and duplicate it. The only difference that you're really going to have is under acidic condition, I will have this carboxylic acid protonated, and I would also have this nitrogen, because remember the amines are very basic, so they can also get protonated, and that'll get a positive charge in there. So that's really going to be the differences. So whenever you're trying to, so this would have HCl, water, you can say, or they may just say H3O plus. and heat. Either way is fine. Um, so remember, whenever you're trying to hydrolyze these amides, make sure you know whether you're doing this under acidic condition or basic conditions and go from there.